All right, lesson 2-3, rate of change and slope. So in this lesson, we're going to be talking about the rate of change, how to find a slope from a graph, and how to find the slope between 2 points. So again, to start with some vocab. So rate of change, this simply means a ratio. And specifically, that ratio compares how much one quantity changes on average relative to another quantity. So it's basically the change in y over the change in x, or shorthand we could use delta y, delta x. So that means kind of the same thing. So to get us warmed up for this, if we do an example real quick, it says the graph shows the number of gallons of water in a swimming pool as it is being filled. At what rate is the pool being filled? So as we're looking at this graph, so it looks like we have some labels, so time. So from 0 minutes up to 10 minutes. And then this is our gallons of water. So it looks like we're going from 0 all the way up to 300 gallons. So that's a lot of water. But if we are finding our rate of change, we're just finding the difference. So the change in y. So it gives us some 2 points here to help us get started. So we need to figure out what that change is. So let's just take 252 minus 108. Over our change in x. So that's going to be the x value, so 7 minus 3. So we just need to kind of do some simple arithmetic to help us figure that out. So let's see, 252 minus 108 is going to be 144. So 144 over 7 minus 3, which is 4. And then if we can, we want to simplify that. So this is a nice number. So 144 divided by 4 gives us 36. So what does that number mean? Well, that means that there is 36 gallons of water being added to the pool every minute. So 36 gallons per minute, that is our rate of change. So 36 gallons are being added to our pool for every minute. All right, let's add some here. So typically we think of this as slope. So slope is a rate of change of a line. So we need at least 2 points. So here we have x sub 1, y sub 1, and then x sub 2, y sub 2. So again, we have delta y over delta x. And what we actually just did up here was showing this. So if we look at this, this would be our x2, y2 if we wanted to match our coordinates here. And then here, this is our x1, y1 for that point. So we're just finding the difference between them. Now really, the order that you subtract in does not matter. What matters is if you start with the second coordinate, that also matches. So the y2, x2 have to line up, or the y1, x1 have to line up vertically when you're doing this. This is the important part when we're doing the algebra. Okay, and again, our slope is going to tell us how steep a line is and in which direction it slants. So if it's positive, it's going to slant up. So positive is going to go this way. If it's negative, it's going to slant down. And again, depending on how big our number is, that's going to tell us the steepness. So if we had something like 10 as our slope, that's going to be a super steep line. So something that looks like this. Versus 1/10, that's going to be a very, not shallow, but it's going to increase very slowly. So it's going to be more like this. So it's very flat, if we want to think of it like that. Okay. So let's do some examples. First thing, if we are finding the slope between 2 points, again, it's just our change in y over change in x. So we would do 1 minus 2 over negative 8 minus 3. And then we're just simplifying that. So 1 minus 2 is negative 1. Negative 8 minus 3 is negative 11. And when we simplify, this would just become a positive 1/11. All right, next one. So negative 3 minus 5 over negative 6 minus a negative 2, so that's going to become plus. So again, simplifying, -8 over +8. So that will simplify to be a -1. Right, continuing, we would have 11 minus 11, and then -3 minus 6. So that gives us 0 over -9. And 0 divided by any number is always just 0. So this would actually be, if we graphed it, this would be a flat line like this. Okay. This one would be pretty close, it would almost look flat. So, and this one would have a negative slope, so it would actually slope down like this. Okay. All right, let's go to our next one. Ooh, fractions. So, looks like we have 2/3 minus 5 over 6 over 1/3 minus 4/3. So, rules for combining fractions, we need a common denominator. So between 3 and 6, our common denominator is going to be 6. So that means that I can multiply this fraction by 2 over 2. So it will change to be 4/6 minus 5/6 over, and then here we already have a common denominator, so we can just simplify that one right away if we want. So 1 minus 4 gives us -3 over 3. So again, continuing to simplify. 4 minus 5 is a -1 over 6. And then -3 over 3, well, that's just -1. So now I'm taking something and I'm dividing it by a -1. So since they're both negative, it's going to become positive. And anything divided by 1 is always just whatever we're dividing. So this is going to be a positive 1/6 for our final answer. All right, next example, we have -1 minus 5, and then -3 minus a -3. So again, that's going to become a plus. So -1 minus 5 is -6. -3 plus 3 is 0. Well, we're not allowed to divide by 0. So if this happens, we're going to write undefined. Okay, so we're not allowed to divide by 0. So if we're thinking about a graph, this graph is actually going to have a vertical line like this, which is not allowed because it's not a function. So anytime we divide by 0, that is an undefined slope. Okay. All right, next one. So again, more fractions here. So it looks like we have 2/3 minus 2/3 over 11/7 minus 4/7. So, oh, that's nice. We already have a common denominator. So 2 minus 2 is 0. So this is 0/3 over, and again, we already have a common denominator. So 11 minus 4 is 7. So 7 over 7. So again, continuing to simplify. 0 over 3 is 0. 7 divided by 7 is 1. So 0 over 1, again, just simplifies to be 0. So that would be our final answer for that one. Now we can also find slope from a graph. So there's 2 ways that we could do it. First way, we could physically just count. So I'm going to make some dotted lines here so I kind of have a better idea of where my numbers are. So if we want, we can just count. So here we would go over 1, 2, 3, 4, 5, 6. So that's my x, so that would actually be in the denominator. And then we're going, let's see, 1, 2, 3, 4, up. So and then if we simplify that, that would simplify to be 2/3. Now the other way to do it is to actually identify 2 nice points on our graph. So if we just take this point right here, this is at -2, +1, and then this point is at, let's see here, 1, 2, 3, 4, -6. And then we're just finding the slope between 2 points. So the same way we did it above, we could also do that here. So -6 minus 1 over 4 minus 2. So that gives us -7 over 2. And we can't simplify that, so this would just be our final answer. Or again, you can count, but sometimes when you are having to deal with large graphs, counting can get a little tedious. Or if they're not counting by ones, that can also affect if you count. So this way will work every single time. This way is okay with smaller graphs. All right, looking at 10, so again, this one, if we identify our points, it's at -2, 3 for that point. So -2, 3. This one is at 3, 3. So again, this would be 3 minus 3 over 3 minus a -2, so plus 2. So that's 0 over 5. So again, that's just 0. Now for this one, we don't really need to go through all this work, because if we look at it, we can see that it's a flat line. So we're not going to count up at all. So we can just assume then that that's automatically a 0. So if you look at this graph and you want to jump right to the answer, that's completely fine. Okay. Same thing on this one. This one is completely vertical. So that means that we're going to end up dividing by 0. So this slope is undefined. Now again, we can go through the work to mathematically check that. So again, this point is going to be at 1, 3. And then here we have 1, -1. So -1 minus 3 over 1 minus 1. So that would be -4 over 0. So again, that's going to be undefined. But again, if we're looking at this, if we can see that it's vertical, we can just go right to our answer. And that is going to conclude section 3.